Our next example in section 8.3 part 2 deals with the birth rates in the United States for the years 1997 to 2006, and they're given in the table. This is example 3. So we see that in 1999, the birth rate was 14.7 live births per 1,000 in the population. For every 1,000 people, we had 14.7 live births. We can see in 2003, for 1,000 people, we had 14.1 live births. So part A is asking us to describe a random variable that's associated with each of the data. Well, when we look at this, the different numerical outcomes for the live births range from, I'm going to start with 13.9. So X, I'm going to start building part B. So actually, I shouldn't do that. Let's not do that. Let's go ahead and come in. So we know that we've got 13.9 is a possibility in terms of the live births. We'll also say that the next value is 14.0, trying to put them in numerical order. I've got a 14.1. I have a 14.2. I don't have a 14.3, so I don't need it, or a 14.4, but I do have 14.5, 14.6, and a 14.7. So those are the different values that the number of live births takes on. So those are our random variable x's. Okay, now that we have that, let's come make a probability distribution. Now the handout again shows a chart going left to right. Because they're going to ask us the variance and standard deviation, I'm going to run mine down the board just to make it easier on us. So here is our x, and here's the probability associated with x. So we said 13.9 is the first one. And we had 14.0, 14.1, 14.2, no 14.3 or 14.4, but there's a 14.5, a 14.6, and the 14.7. Okay, the next thing we need is the probability that each of these occurs. Well, the 13.9 occurred only one time. So it's 1 out of the total of how many years do we have going on here? We've got 10 years, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this occurred once out of 10. Well, that's 1/10, which is 0.1. So the probability is just going to be 0.1. And again, that was 1 out of the 10. So I'm going to cross that guy off so I know that I got him. 14.0 only happened one time. Nope, twice. So it happened twice. So that would be 0.2. 2 out of 10 times is 0.2. 14.1, let's see, just one time? Nope, 2 times also. So it's this one and this one. So that would be 0.2 for that one. 14.2 was just the one time at the end. So it's 0.1. Let's see, 14.5 occurred twice, so 0.2. 14.6 occurred one time, and so did 14.7. 0.1 and 0.1. If we've done it correctly, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough, they sum to 1. So fantastic. There's our probability distribution. Okay, so the first thing we need is the expected value in order to find the variance. So part C is asking us to compute the mean, variance, and standard deviation. So again, mean, variance, and standard deviation. The mean is our expected value, so we have to go find it as our first step. To find the mean, again, we take 13.9 times 0.1 plus 14 times 0.2 plus 14.1 times 0.2, 14.2 times 0.1, and add them all together. So our mean, which is a mu or e of x, came out to be, when we did it in a previous section, 14.26. So that was our mean. So the average birth rate for 1,000 of live population between 1997 and 2006 is 14.26 live births. Okay. Now we're going to come in, and our next column is basically going to be the probability times x minus mu. So in this case, it would be 0.1 times 13.9 minus 14.26. And then we're going to square it. And again, the reason you square it is to deal with any sign issues that occur with the subtraction step. Okay, we're going to need to query quite a few decimals here in order to make this thing come out correct. So when we did that, we got 0.01296. Okay, so the next one would be 0.2, and then we're going to take 14.0 minus the 14.26. 0.26 and square it. And if you do that, we ended up with 0.01352. The next row, we're going to take our probability of 0.2. We're going to multiply it by 14.1 minus the 14.26 quantity squared. And we have 0.00512. Next one is 0.1 times 14.2 minus the 14.26 quantity squared. And that one came out to be, notice that these are decreasing in size because our value is getting closer to the mean. So you see that it's large, gets smaller, 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 and then we're going to see the reverse of that. It'll start getting larger the further away from the mean we get. So in this case, we've got 0.00036. The reason to note that is as you're punching them into your calculator and you make a mistake, that's going to help you identify those mistakes. So we have 0.2 in the next line times the 14.5 minus 14.26 quantity squared. And that one came out to be 0.01152. Each of these numbers is describing how far away this value is from the middle. Our next one is the 0.1. Now we're going to take 14.6 minus the 14.26 quantity squared. And because we're getting further away from the 14.26, we see these numbers getting a little larger. 0.01156. So the difference here is this probability of 20% versus the 10%. And then finally 0.1 times 14.7 minus 14.26 quantity squared is equal to 0.01936. And hopefully, again, you're checking these on the calculator. To find the variance, we need to sum that column. So down here, we're going to find the sum. And that came out to be 0.0744. 0.0744. So the variance is that sum, 0.0744. And again, the reason we like the standard deviation is it takes the square root of that, which undoes the effect of the squaring. So our standard deviation is going to be the square root of that. Square root of 0.0744 comes out to be 0.2728. And that's our standard deviation. So it's a pretty small spread. So this is telling me that because that number is so small, less than 1, right, that we're fairly close to that 14.26, which we are. Our data set was fairly close to it.